19 square root of 20. Okay, this one's not a perfect square, so we're going to have to do a little factor tree. 4 times 5. Now 4 is a perfect square, so the square root of 4 is 2, and 5 just comes down, so that's going to be 5 square root 2. Okay, let's look at number 19, square root of 48. Now a couple ways to do this one. Okay, I can take the largest factor that I know, and I know 16 times 3, it multiplies to 48. So I can actually factor this down as 3 times 16, and then 16 is a perfect square, and its square root is 4, so that means that's going to be 4, and I'm left with a square root of 3. Okay, now there's another way to do that one. If you did it a different way, that's fine. Okay, let's look at number 20. We have 3 square root 9. Okay, 3 square root 9. Well, the square root of 9 is a perfect square. It's 3. So I have a 3 on the outside, and then the square root of 9 is 3. So I'm just going to take those and multiply them together. So that answer is actually just 9, because 3 times 3 is 9. So whenever you simplify, you're going to multiply by that coefficient in front of the radical. Okay, let's go back, and you can rewatch any of those if you need to. Okay, let's look at number 21. 21 is 5 square root 12. Okay, now 12 factors into 4 times 3, and 4 factors down to a perfect square of 2. So I'm going to take a 2 out. So 2 times 5 gives me a coefficient of 10 on the outside. Now we don't have 3 is not a perfect square root, so I'm just going to bring it down. So the answer is 10 square roots of 3. Okay, number 24. You've got square root of 50. Okay, square root of 50, I'm going to show you 2 ways to do this one. You could just start doing a factor tree and say, I know that 5 times 10 is one of the factors, and then 10 factors into 5 times 2. So my prime factors are 5 times 5 times 2. And then you look for pairs. So I have 2 5s. That means it's a perfect square. So I can take that out of the radical, and I'm left with 5 square root